first presenter we've got is Andy Hayner, and just a couple special things about Andy. He's a lead meteorologist with the Weather Service out of Tallahassee. I looked at his background and I noticed he made a giant diagonal move. He had been a meteorologist in Seattle, and then went to Key West all the way across the country, and then he came up here to Tallahassee from Key West. I've had the honor of working with Andy in my current position and really have learned a lot from him. And one thing I wanted to learn from him and ask him, each presenter, I've got a difficult question, and Andy's difficult question you can start with is, what is your least favorite weather system in Florida and why? We'll take it away from here.
All right. Man, after this year, least favorite weather system would have to be a hurricane. Turn an entire office full of meteorologists into a bunch of chain smokers. But in the fire environment, I would have to say watch out situation number 15, if my memory is right, which is sudden increases and or changes in wind. So basically, of course, firefighters, fire lighters, you're a very adaptable bunch. I know that you can move quickly and respond to changes in the environment, but I'm talking about like thunderstorm outflows or those kinds of wind shifts that come so quick that you don't have time to adapt to them, and then watch out situation number 15 applies. So yeah, actually I'm glad you posed that question. So yeah, of course I came with some material today, all kind of focused on weather. The first two items up there on the outline are it's material that we cover every time. We're going to go back, look at the last couple of months, especially as it pertains to rainfall. We're going to look at what's going on right now and the forecast for the next couple of weeks, and then look at the climate outlooks going out all the way into next spring. Of course, meteorologists, we forecast weather out to 7 days, and then climatologists pick up and forecast from day 8 on out to years and years into the future. So also, I like to come with some updates about the Weather Service. So I'll be talking a little bit about the rollout of the new spot forecast page that took place back in June. I know I touched on this at the last meeting in the spring over in Tallahassee, but I'll touch a little bit on the elimination of LAL and Haynes Index from fire weather forecast coming up early next year. And then just kind of, for the futurists, the big picture people, I'm going to be taking a little look here at where weather forecasting may be going and how especially just, leaning forward a couple of years into the future, how forecasts may be communicated a little differently moving out into the future. So that's the last item coming up. So first of all, let's review what's happened over the last few months. So I'm going to go back starting in August, looking at rainfall. And first of all, July actually was a pretty wet month. We had pretty normal wet, rainy season up to that point. But once we got to August, the rainy season, just that rhythm and pattern of daily afternoon thunderstorms seemed to really kind of diminish. It's like the spigot got cut off. But of course, we did have Hurricane Debbie come along in early August. And so, from the west coast of Florida, the Sarasota and Tampa Bay area, all the way north up through, Taylor, Madison counties. That was just a Noah's Ark level rainfall that happened there. So what you're looking at here, the colors, that just represents the percent of normal rainfall for the month of August. So you can see that where Hurricane Debbie dumped its rainfall, I think parts of Madison County ended up with a 200-year rainfall out of this. But once you get Tallahassee westward, really missed out on a lot of rainfall. You can see rainfall was quite a bit below normal. Even if you can't read the legend, the colors kind of tell you it was dry. So moving forward into September, with September, we ended up with Hurricane Helene during the second half of the month. And even in the days before Helene came along, areas up through the Apalachicola Basin were getting lots of rainfall. Then Helene came along and we got even more rainfall. And of course, you see that swath of just incredible rainfall, heading north up the Chattahoochee and through Georgia, and we all know what happened up in the Carolinas as well. So some areas that had been dry in August ended up getting really wet in September from Helene. But one area I want to point out that was dry in August and was dry in September was the Western Panhandle. You get out to, Escambia, Santa Rosa, Okaloosa counties, even to a lesser extent, Walton County. And it was a dry August and a dry September out there. And the last thing I'll show you as far as past rainfall is concerned, this is just the rainfall map from October 9th through 11th as Hurricane Milton came in. Once again, locations from Tallahassee. Oh, actually, that's right. Let's back up to September. I wanted to mention, a statistic that Apalachicola had 26.9 something inches of rain for the month of September, which made September for Apalachicola the wettest month going back all the way through the 1930s. I think there was an unofficial record from the 1920s that had more, but basically this was the wettest month on record for Apalachicola going back 90 some odd years. So I wanted to get that in there as well. So now moving forward to Hurricane Milton. Milton dropped just incredible rainfall amounts down in the Tampa Bay area. In fact, if you're traveling north on I-75 from Tampa, you pretty much had to get all the way up north of Wildwood, where the turnpike comes in, to get less than 10 inches of rain just from Milton alone. And by the time you get up to Tallahassee had, I think, about a quarter to a half inch of rain from Milton and then nothing. So once again, the Western Panhandle missed out in August, missed out in September, and has also missed out in October. So things, I'm sure you already know, things, especially out in the Western Panhandle, are really dry, while down in Central Florida, things are really wet. So there's quite the gradient of moisture moving from the Western Panhandle in toward Central Florida. And really, the dryness out in the Western Panhandle is pretty characteristic of the dryness that you see going all the way out west into Texas. Louisiana got some rain back in earlier in September, I think, from Hurricane Francine, but that's about the only exception to the rule. So really what's going on in the Western Panhandle is kind of the eastern extent of, a much larger area of dryness. This is the Keach-Byram Drought Index from yesterday that you're looking at. Okay, so what I'm showing you here now is the U.S. Drought Monitor, and I'm just gonna zero in on Florida. Once again, you see that designation of abnormally dry out in the Western Panhandle. The rest of Florida is not considered to be in drought right now, but I think, based on the forecast that I'm about to show you, we're going to be seeing some of those drought designations ramping up here in the weeks and probably months ahead. So this is actually just a forecast of rainfall for the next 7 days. And all that white space over Western Florida and then up into North Florida, all the way out through the Panhandle means no rain is expected for the next 7 days. The climate outlook for 8 to 14 days into the future shows odds leaning heavily toward above normal temperatures. So warmer than normal temperatures. That's the left-hand graphic. In the right-hand graphic, basically as we get out toward Halloween, the first few days of November, it shows rainfall pretty close to normal, really. So, although keep in mind, normal rainfall in late October and early November isn't a lot of rainfall. We're heading into what for Florida is one of the drier times of year. The drier times of the year being kind of the heart of fall, which we're heading into now, and then late spring, that time, usually April and May before the summer rainy season kicks in. Here's the 3 to 4 week outlook. So this is basically the first half of November, showing odds leaning pretty heavily toward below normal rainfall. That's the graphic on the right. And then, looking out even more than a month into the future, now we've got to start to talk about some of these cyclical climate phenomena, such as El Nino and La Nina. We are currently heading into a La Nina. Some would say that's part of, one of the contributors to the active hurricane season that we've seen so far. And what you're seeing here, all those graphs, all those bars in blue, that represents the chance of La Nina as you move forward, pretty much about 9 or 10 months out into the future. So you see through the winter, odds are strongly in favor of the La Nina climate phenomena. And then as we get out late in spring and early summer next year, there's really, we're basically forecasting a return to neutral conditions. So what is El Nino and La Nina? Well, we're forecasting La Nina for the winter. So La Nina has a pretty good signal for the winter. And by good, I mean, fairly reliable. What it ultimately does, the graphic on the left kind of shows you how the jet stream tends to consolidate across the northern half of the country. And so the northern half of the country tends to be colder and wetter than normal in a La Nina winter. But then the southern half of the country, including Florida, ends up being warmer and drier than normal. We just don't get as many, wet cold fronts. The jet stream energy is usually displaced to the north. But I'll give you a caveat here with the La Nina and the warmer and drier. With that consolidated jet stream, just one good undulation in the jet stream, and suddenly, it's easier to plunge some Arctic air into Florida. So, you could have a whole winter, or most of a winter at least, with above normal temperatures, highs in the 70s, maybe near 80. But then, La Nina winters are prone to getting a hard freeze at some point in the midst of it all. Big nasty cold front comes through with hard freeze conditions behind it. That lasts, of course, in typical fashion for just a day or two or three. We all know cold weather usually doesn't stick around too long in Florida, and then back to warmth. So that's not part of the official climate outlook, getting a hard freeze in Florida, but I think this is going to be one of those winters where a warm winter, but then at some point you're going to find yourself with a lot of freeze and frost kill. So here's the official climate outlook moving out for, this is on average for the months of November, December, and January. And you see, that indication of above normal temperatures across the southern half of the US with below normal rainfall. And so this is actually the drought outlook moving all the way out through the end of January. And so all those areas in brown are places that are already currently in drought. And so the areas in yellow are areas where drought is expected to expand to through the end of January. And this forecast, they put this forecast together once a month, and it was put together just 5 days ago. So this is a pretty fresh forecast. And so you see that forecast of drought development out in the Panhandle. Of course, they've had so much rain from Debbie and Helene and Milton that to get an actual drought designation, I suspect it's probably coming before the end of this winter season, but it may not come before the end of January. But nonetheless, we all know you get 7 to 10 days without rainfall around here, and things are usually ready to burn. So here is the significant wildland fire potential outlook. Again, this is more geared toward wildfire and large wildfires at that, the ones that take a lot of resources and money to handle. But November, December, January, they all pretty much look alike with the forecast of above normal significant wildland fire potential over the southern plains. Again, that goes in line. It's already been dry out there, and it's expected to remain dry. These outlooks don't go beyond January, but I'll show you the climate outlook that was put out last week for the months of February through April. So now we're getting into kind of the heart of the late winter and early spring burn season. And it shows odds still leaning with La Nina in effect of above normal temperatures, warmer than normal temperatures, and drier than normal rainfall. So really, that's the big story right there. Is pretty much from now looking forward all the way through April, we're looking for below normal rainfall. So as you consider your burn plans for the rest of this year and moving out into the spring, you may want to be counting on drier than normal conditions with a hard freeze at some point to kind of kill things off as well. So as far as the outlook, this is kind of the summary of that. Obviously, I've got more material, so But basically, the official forecast from the predictive services units through January calls for near normal fire potential. But I'm going to lean forward and say that once we get past January, we're looking for above normal wildfire potential. Okay, so we're going to shift gears now. And last time I talked to you over in Tallahassee back in March, I mentioned that we were going to be rolling out a new version 2.0 of the Weather Service spot forecast page. And of course, at the time, I mentioned that the move was intended to increase reliability, functionality, and supportability of the application. I think that was something that was put together by a consortium, probably a task force of our public affairs people and our computer people. So it rolled out somewhere in the June 20s, and the rollout was pretty, I don't know, it was kind of troubled, really. Thankfully for us here in Florida, July, August, and September, are the months where this page is used the least for requesting spot forecasts for prescribed fire. But if you were out west this summer fighting fire out there and you were at all involved with requesting spot forecasts, I know that the Western U.S., the Weather Service offices in the Western U.S. really bore the brunt of working out the bugs of this thing after a rollout that took place at the beginning of the Western wildfire season. So thankfully, at this point, it looked like as of about mid-September, most of the worst bugs had finally been worked out. And so as we head into our winter season, our prescribed, our more traditional prescribed fire season around here, I'm pretty sure that this thing is going to work the way it's supposed to. But if you have any feedback, as you interact with the spot forecast page, if you have any feedback, obviously you're welcome to reach out to me. The people who actually, have pull the bells and whistles basically on the spot forecast page, you can reach out to them at nws.webfeedback@noaa.gov. nws.webfeedback@noaa.gov. Okay, shifting gears again, I mentioned back in March that the Weather Service offices in Florida that, through the Fire Weather Annual Operating Plan that we signed, in partnership with our land management partners, that we were changing to issue a red flag warning. We have to have a prerequisite level of dryness. We're not going to issue a red flag warning even if it's dry and windy if the fuels are wet, right? Well, previously our criteria was based on ERC values, but with the last rollout of the newer NFDRS, we had a bit more trouble getting ERC data. So we actually changed things up. All the offices in Florida were now using the brown or moderate category of the significant wildland fire potential outlook that is issued by our partners at the Predictive Services Unit at the GAC, basically the Geographic Area Coordination Center up in Atlanta. So I just wanted to mention that again for those who were not around back in March. Let's see. This is just a little flow chart on how those values in the significant wildland fire potential outlook are derived. And it's really a pretty, I honestly, I love that outlook. They take a pretty holistic approach to coming up with the outlook. They're looking at, of course, they're looking at fuels, they're looking at weather, and they're even, I think somewhere down in there, there's even a resource component. Wildfires, of course, are more likely to get out of hand if there's nobody to go out there and fight them. So they even take that into account. So by the time you get up to that brown or very dry category, they're basically forecasting a 10% chance of a new large wildfire on that day over a pretty large geographic area. And so this is, of course, just a map for today showing today's significant wildland fire potential outlook. And so you can see, getting up into the Panhandle in North Florida, it's brown. You get down into Northeast and Central Florida, and it's green. Basically, with all the wetness down there, there's almost no chance of getting a new large significant wildfire today. So anyway, we're now using this. My biggest point in all of this is that this is what we're now using for the prerequisite dryness in driving our decisions on red flag warnings. And actually, one of the cool things is that we've been talking with the Weather Service has been talking with our land management partners up in Alabama recently, and we're now just waiting for the final sign off on a new AOP up there that will basically get them to using the same prerequisite dryness. So if you've ever noticed before, like red flag warnings getting cut off along state lines, let's face it, the weather doesn't change that drastically across the state line. So I think you'll be seeing less and less of that as even the criteria for Florida, the criteria for Alabama, and we'll be working on Georgia soon, but as the criteria for the different states better comes into line, you'll see fewer red flag warnings cutting off along political boundaries. Okay, moving forward, I mentioned this back in March as well, but starting in January, we are going to be eliminating LAL, that's short for lightning activity level, and Haynes index from fire weather forecasts all across the US. Here in Florida, we've never included Haynes index in the forecast, so this will have no impact on Florida-based folks. You've probably heard it if you've spent some time out west, but why are we getting rid of these things? And I'll say, from a big picture standpoint, it's to get rid of unnecessary information overload. If we're giving you an index that doesn't really mean anything or that is already represented elsewhere, then it just, I don't know, for me, I can only remember 3 things before I have to start writing things down and doing all kinds of crazy mental acrobatics, So anyway, so LAL, first of all, lightning activity level is redundant. LAL, just goes on a scale of 1 to 6. Since we're getting rid of it, I won't go into it in detail. But basically, on that scale of 1 to 6, it tries to represent basically how much lightning is gonna be occurring. But that's already, represented in the general weather forecast. If we say slight chance of or isolated thunderstorms, that's the same thing as an LAL2. If we're saying scattered thunderstorms or chance of thunderstorms, that's already an LAL3 or maybe 4. So again, it's all redundant, and so that's the basic premise for getting rid of LAL. And then for Haynes index, I'm mainly showing this for the benefit of folks who travel outside of Florida to fight fire. Haynes index it runs on a scale of 2 to 6. It's meant to represent dryness and stability, or dryness and instability, at some elevated layer up in the atmosphere. And so, there's always been this mid-level Haynes index that represents conditions in that 5,000 to 10,000 foot layer of the atmosphere, and then high-level Haynes index that represents conditions above 10,000 feet. But really, I think what we've been discovering over the years is that the most important thing that affects fire behavior is what's going on right on the ground, right? And so, yeah, on a typical spring day in Florida near the coast, our mixing height is usually somewhere in the 500 to 3,000 foot range. So it never even gets up into that mid-level Haynes layer. And then over the interior, once you get away from the coast, then the typical mixing height is about 3,000 to 5,000 feet. So once again, it just barely even nudges that mid-level Haynes layer. So once again, certainly here in Florida on almost every day, Haynes index is useless. And even out west, there are only a very few places where it's actually truly useful. And certainly you can get conditions that are dry and unstable above 5,000 feet, but if you never mix up above 5,000 feet, then it's useless. So anyway, so hopefully, you'll feel less overloaded with useless information as we get out to January, but I know that there's also a lot of people who have been used to seeing these in fire weather forecasts for decades. And so that alone might be a change. So if you get to January and you're like, where's the LAL? Well, it's been eliminated by design. It's not a mistake. Okay, the last thing I am going to touch on here is, and I almost thought about going into this without any slides, but I decided to throw this in because this past week, our office, our forecasters, we had training. We had 4 hours of in-office training on how to basically better express the forecast probabilistically. Now, for my entire life, I think, you're all used to hearing, a certain chance of rain. There's, of course, we're the butt of a lot of jokes for saying 50% chance of rain, how can you go wrong with that? But so you're all used to hearing things about the chance of rain. But in recent years, we can now give a chance of pretty much any weather element you can shake a stick at. We can give a percent probability. For example, if you've got a burn prescription where you're not supposed to burn below 25%, we now have the ability, at least in-house, to give you a percent probability of the RH staying above 25% or going below 25%. I know, say if 25% is your cutoff for a prescribed burn, I know a lot of you are probably still looking for that deterministic forecast value. You just want to know, well, how low is the RH going to get today? But we all know there's inherent uncertainty. There's kind of a range of possibilities in the forecast. And so we ourselves are getting trained now in better how to express that and how to come up with and express that probability. So, for most of my career, actually, it's kind of funny today is my 13th wedding anniversary. So, yeah. And when my wife and I first met, long before she was my wife, she, of course, wanted to figure out if I was a creep. So she did an online search, typed in Andy Hayner to see what would come up. And of course, I was a meteorologist. And so, the top things that come up are things like newspaper quotes. And so, in fact, there was apparently a website called quotables.com. I don't know if it even still exists anymore, but apparently it rates people by their most famous quotes. And my most famous quote at the time that we started dating almost 14 years ago was, "It's not impossible, but it's unlikely." I mean, and of course she instantly knew, okay, this guy really is a weatherman. So, I had my 30th anniversary with the Weather Service this year. So through decades of on-the-job training, I've learned the art of being like Jello that you try to nail to a wall. There's always a way out. So of course, I spent 16 years as an IMET, and a lot of times people would ask me out at fires things like, "So what's your gut feeling on this?" And so it's like, and of course, especially actually there was the guy who trained me as an IMET, he had a big gut. And so he really liked to talk about his gut feeling. So, there's also, we use words like possible, chance, non-zero chance. That's one of my favorites. Of course, non-zero chance means there's very small chance, but it doesn't omit the fact that there could be a very large chance. It's non-zero. So using words like unlikely. So what do these words really mean? And actually, sociologists have spent years trying to figure out what these words mean. And they've done surveys of college students and the public, and words like likely, they've figured out that the public thinks that means somewhere between a 40 and 80% chance of occurrence. So yeah, it's kind of interesting. And I think so for probably the past decade, meteorologists have been trying more and more to pick out the right word to describe the probability that we're trying to convey. But why not just, bust out an actual probability? So clearly, with the training that we just got this past week, we're going to be moving toward probabilistic forecasting in more areas than just the chance of rain as we move out through the next, I'll say, 5 years. The thing that I think is going to be most relevant for prescribed burners is this thing that we call exceedance threshold. In fact, I already kind of alluded to it, where say 25% is a critical value for you. You know, and so, you've been used to getting a forecast that says, the min RH forecast today is 30%. But what would it mean to you? And this is a rhetorical question. I actually want you to kind of chew on this over the next few months, maybe by the time I see you again, hopefully in March. What would it mean to you if we said the min RH forecast today is 30%, but there's a 2 in 10 chance that it could fall below 25%? Would that mean something to you? So that's just something to chew on. How could you, as prescribed burners, possibly use that information? Could you use it? So this is something that, probably over the next 6 months or year, as I talk with you, I may be asking you some of that very question in casual conversation offline. So give it some thought. I'd love to hear your thoughts on this. So with the training we had the other day, in kind of some non-fire areas, we're learning to say things like, low chance within like a percent chance in parentheses, like low chance, medium chance, high chance. I think you're going to see that verbology in our social media posts more often. Also, we're going to be trying to tie things in more to climatology. For example, what I mean by that, let's say this first one here, there's a medium chance, 20%, of getting a tornado somewhere in Jackson County today. So 20% to most people sounds like a pretty low probability until you consider that on any day of the year, there's less than a 0.5% chance of getting a tornado in Jackson County. So, when you start to look at a probability like 20% and tie it in with climatology, which is less than 0.5%, it's like, oh, the odds are 40 times greater today of getting a tornado in Jackson County. This is hypothetical, of course, than on any other day of the year. So that was part of the training we got, tying things into climatology. Of course, forecasting rainfall is a pretty big deal. So, you might be used to hearing us say things like, we're forecasting 2 to 4 inches of rain, but usually it's those high-end rain amounts that have the biggest impact. And so you might hear us say things like there's a 1 in 10 chance of the rainfall exceeding 8 inches. In fact, when we talk about like that 1 in 10 chance of exceedance, we're also calling that a worst case, a reasonable worst case scenario. So especially, for emergency managers who might be trying to plan for a worst case scenario, basically, you don't want to get caught with your pants down, so to speak. With storm surge forecasting for hurricanes, anytime you hear storm surge forecast along the coast for a hurricane, that is always a reasonable worst case scenario. In other words, there's only a 1 in 10. The way that the folks at the Hurricane Center zero in on that forecast, that storm surge forecast, is they only want a 1 in 10 chance that the storm surge forecast is going to be exceeded at any location along the coast. They do not want to under forecast storm surge, for example. So there again, another phrase there, that reasonable worst case scenario is basically a 10% exceedance. Okay. So there we go. So again, exceedance threshold, that's the thing that I think, as I think about, uses in prescribed fire, I think that could have when we talk about this move in the years ahead toward probabilistic forecasting, I think that's going to have the biggest application to prescribed burners. So for now, we can already basically go into our database and pull out some exceedance thresholds. So for now, like, for example, if you're requesting a spot forecast from us and you want the exceedance threshold, for like, say, you want to ask for the percent chance that the RH is going to drop below 25%, just put that in the remarks section of the spot forecast request, and we will address that probably up in the discussion. But anyway, this is going to be something that that is going to be, it's basically the future of forecasting and how we communicate forecast. We're probably going to be getting away from words like gut feeling, unless of course you have an IMED at your disposal, but anyway. Actually, as far as how do we come up with these probabilities, it's not just something that we pull out of the hat, so to speak. I know that especially if you're a weather geek, you've probably already seen, especially for hurricane forecasting, things like spaghetti plots. Anybody in here seen or heard of a spaghetti plot with hurricane forecasting? Okay, so that's probably just over half. Basically, what a spaghetti plot is it takes we have our computer simulations, our computer models. So by the way, this is kind of the if this were one of the For Dummies book, a Weather for Dummies book, this would be the little nerd part. The guy with glasses, but you probably have to be over 40 years old to know what I'm even talking about. But anyway, so those spaghetti plots, they use what we call ensembles, which basically it's kind of interesting. You can take our global weather model, the one that we use to forecast weather all over the world, and the ensembles basically run by just slightly perturbing the initial conditions, that initial snapshot of the weather. And by the time you take even small changes in the weather and translate them forward, days or even weeks out into the future, those small changes in what's going on right now become bigger and bigger and bigger changes as you move forward in time. And so like with the hurricane spaghetti plots, which probably the most number of lay people are familiar with, what it basically does is it takes those models, provides just a slight perturbation of the initial conditions, and then you start to see all of these possible different tracks for the hurricane. We can basically take that same approach and apply it to day-to-day weather forecasting, and that's basically how we're able to come up with these exceedance thresholds. So anyway, give it some thought. I'd love to just converse with you, see if there's any possible use for this in the future. And that's all I got. So if this is the phone number, by the way, for every weather forecast office in the state of Florida. I'll leave that up there for about 15 to 20 seconds, just in case you want to be able to reach any office in the state of Florida. These are numbers that we answer 24/7. So, and I throw this up here too, once again, kind of going into watch out situation number 15. If you're out in the field, you're doing a burn, I don't care who you are, if you're a contractor or a government employee, especially if you're looking at something that is that could, threaten life or safety, pick up the phone, give us a call, and we will be happy to tell you what we see. If a thunderstorm outflow or if a distant thunderstorm that you see, if the outflow might possibly get to you. So yeah, we'll talk to anybody. Okay, so that's it. That's my email address, and looks like I know I started about 10 minutes late, so I've got looks like about 3 or 4 minutes for questions.
I got a question for you.
Yeah.
Before the questions, are you here after lunch?
I'll be here till about 2 to 2:30. So,
okay.
Yeah.
If you don't mind, I'd like to change up our schedule just a bit. We've got a blank spot where we had some lessons learned a little bit after lunch, and I'd like to circle around and give more time for questions for you,
Okay.
and kind of a catch-all for some other questions we might have too, if you don't mind doing that.
Yeah, that sounds great.
For questions for now, and get right into our next presentation.
Okay.
That's okay.
Sounds good.
Thank you, Andy.
Yeah.